Okay, so here we are, another question. Let me take a moment to make sure that the audio is working. Take a moment to pop the chat out. Maybe my internet connection is having some trouble. Pop the chat out. Hello. Yep, okay, very good. Okay, so what I'm looking for now, yeah, so I'm going to revisit this question here. Happened there. Going to revisit, this is a question I'm going to revisit. I've solved this before, but I want to solve it again because I don't remember exactly how to solve it. And I think it's not a bad idea to go through questions that I've already solved. I always clear my cookies frequently, so I shouldn't have the answer locally. Yeah. I change this to D. So I solved this relatively recently too, like maybe not even a month ago. Give an integer array, an integer difference. Return the length of the longest subsequence in an array, which is an arithmetic sequence such that the difference between adjacent elements in the subsequence equals difference. A subsequence is a sequence that can be derived from array by deleting some or no elements without changing the order of the remaining elements. So here we do have difference of 1, we have 1, 2, 3, 4. Here a difference of 1, we have just 1. And here a difference of -2, we can do 7, 5, 3, 1. Okay, so an interesting approach to this is to actually take each of the elements, so basically run a quadratic time algorithm. Oh no, excuse me, not a quadratic time algorithm. This seems too long to do in quadratic time, actually. Maybe I need to do it in quadratic, and with respect to this, is too long as well. 10 to the 8th is too much. Okay, I don't know the answer to this immediately, and I've solved this before too, so I have to really think about it. I think what I want to do is each number that I see, I want to know, I'm going to assume that number is an ending point, right? And okay, I think that works. I think I can use dynamic programming to do this. Do it in linear time. All right, I'm going to say, so array of values, constant bound is 10 to the 4th. Offset is 10 to the 4th. And I'm going to have this int sort of max val, or I don't know what to call this. Just val bound. I'm not sure what to call it. It's going to be the bound. So it's the bound plus the offset plus 1. These are going to be integers. Try to explain this. This will be a DP. Okay. So in a loop through each character, and I'm going to say, take a look at the previous value. So as I go left to right, I could start that sequence. So if dp of x is 0, increment dp of x, that's one thing. By the way, I'm gonna have this going on here. Another element to this is from that point, I want to see if I add the difference, right? So dp should be equal to dp of x plus d plus 1, right? So if I add so here I see 5, add -2, I see the 7 I already saw, right? Okay. And that should be fine. There's an offset involved, so x plus offset. And then this is going to be x plus offset as well. But even that, x could be -10 to the 4th, and d could be a negative number. Both of these could be, yes, quite negative. Basically, if this value is less than 0, we just use 0. Constant val. If x plus d plus offset is greater than or equal to 0, then val equals dp. So index. Okay, something like this. See what happens if I do this. I get some errors here, compile time error. Okay. I think something like this is fine. If I don't get compiler errors, how am I doing on time? 7.5 minutes, 8 minutes. Wrong answer. Okay, I got the right answer in one of these cases, but the wrong answer in this one. So 1, 2, 3, 4, I got 1, expected 4. So when I saw 1, so okay, all the values are 0. The index is x plus d plus offset. X is 1. X plus d is 2. So I don't see. Actually, I think it's the other way around. I think it's minus d. Did that wrong. Yeah, there we go. Okay. I was thinking about that. I was like, I don't know. Doesn't quite seem right. Okay, so let's try some random sequences. Let's do -10,000. Let's make a difference of 10,000. Just to see if I get any out of bounds errors going on here. Strange off by 1 errors that I don't realize I have. Okay. Let's do like 1,000, 1,000, 2,000, 3,000, 1,000, 2,000, 3,000, 4,000, 5,000, 1,000, 10,000, 6,000. Do this 1,000. You know, I'm tempted to just submit this and see what I get. Maybe just go for it. I'm gonna go for it. I could be wrong. I'm probably wrong. There's a good chance it's wrong. I didn't test it. Yeah. Okay. Oof. Oh. I probably should have thought of that. Yeah. Probably should have thought of that one. By probably, I mean definitely. Yeah, it gets a little confusing, adding and subtracting that d value. Oh, I should have grabbed that test case. Ooh, that was a mistake. Okay, got it. Nice. That's pretty solid. Pretty fast solution. Yeah, that was bad on my part. I don't know. I kind of was like, it's probably some off by some kind of index related error, I'm sure. I should have just tried that. Thought about it a little bit more, I guess. Yeah, because D could be a really negative number, in which case it could actually overshoot, which I just didn't even think about that. I knew there was probably going to be some kind of runtime error because of the boundaries. It's really hard to get it right, quite frankly. To get the I got it wrong the last time too in July. I did like a similar thing. This is a much more efficient solution, almost 100%. I was saying that before. This is like the way to do it if you're gonna use make use of how long do you LeetCode each day? How's it going, Kitchen Raccoon? Hope your day's going well. Welcome. It's kind of random how much I do each day. Some days I do more, some days I do less. Yeah, I try to do like a lot. Like there were times where I would do like 12 hours a day, but the problem is like you really need, yeah, it's like very close to 100%. You really need, the problem with solving online programming challenges is that if you don't know the answer, it's going to take you a long time to think it through. Like it could be really a long time, and I often get really stuck depending on what I'm doing. I'm trying to get 100%, like very close. Excuse me. Yeah, you can get really close and really stuck. So, like you could end up spending hours just thinking about a question without ever actually solving it. And so it's like kind of weird to say like how much do you LeetCode, because it's like, well, if you spent 6 hours thinking about a question, right, but didn't actually program anything for 6 hours, to other people it looks like you didn't spend any time at all. But you would be able to say like, yeah, I spent all that time thinking about it. At the same time, like, did you really spend all that time thinking about it though? Like, how do you even measure that? Like, you would know, I guess, but like you're too busy thinking about the problem to really pay attention to how much time you spent thinking about it, I suppose. Something along those lines. Yeah, I should have been able to. I should have like thought about this a little bit more. I don't know what I could have done differently was just think about like, hey, this could go out of bounds in both directions, and just bound it. Keep it simple. But yeah. My when I apply for jobs, I say that I did it for like 40. I do like 40 hours a week. Sometimes I do like 60 hours a week. Sometimes I do 20 hours a week. It's kind of hard to measure because it's like, I might be spending a lot of time just thinking about a question and not making much progress on it. It just doesn't look very good. But yeah, this is definitely fast. It's not, maybe if I keep running, I can get 100%. I get really close to 100%. There may be something I could do differently here that can get me to 100%. It's not obvious exactly what that is. So yeah, anyway, okay. Pretty good. I wanted to revisit that one because I remembered it and I was like, I think there's a better solution. Not a better solution, but I wanted to double check if I could solve it again. And yeah, that time around it was definitely a lot more efficient solution. Got there a lot faster. Unfortunately, got the wrong answer because I forgot about a bounds check, which is kind of the risky run when you use like hard constants. It can be pretty hard sometimes to like detect whether you're gonna go off the edge of the array. But anyway, so yeah, thank you for watching. If you liked this video, give it a like and subscribe for more. I'm gonna restart on another question. Keep going here. Keep going.